Actually, this stuff what we've been doing already is find the x-intercepts, find the y-intercepts, multiplicities. So we've practically already done this. So let's look at the examples. Example 1. Graph the polynomial negative 2x to the 4th plus 3x cubed. Now, the reason I put on your sheets, the reason I put these boxes here is to help us to look at each part of the function. What intervals do we have? Which intervals are above the x-axis? Which ones below the x-axis? Take a test value. Tell me that'll inside the inside that interval, it'll tell us if it's below or above. So to begin, what we have to find are these. The zeros or the x-intercepts, the y-intercept, the degree, and the multiplicities. Those are the important parts. So how do we find the zeros for this one? X cubed, right? Because they both have 3 x's in common, which will leave us negative 2x plus 3.
What would you call them? Would you factor out? It could just be a factor, like LCD.
A common term. Yeah. Factor out the common term in the entire polynomial. Oh, once you factor that out, can we go any further? No, that's a linear equation. That one can't go any further. So what do we do now? Yeah, set each of these equal to 0. So x equals 0, because if we took the cube root of both sides, it's 0. Move the 2x to the other side and divide by 2. So x equals 3 over 2, or 1 1/2. So the zeros are at 0, 1 1/2. What's my y-intercept? 0. My degree?
4.
And what are the multiplicities? This is how, okay, I should have done this earlier. The multiplicities for the first one is x. What is its multiplicity? X is 3. That's its the exponent is its multiplicity. So it's 3. The other one is negative 2x plus 3. Its multiplicity is 1. If we add those together, we get 4, which is our degree. So let's plot our zeros. At the origin, and 1 1/2. What direction is the graph going? What kind of graph is going to be?
It's upside down, and they're both ones.
They're both going, yes. So we know that this side from here is going to go down, and from here it's going to go down. Is it going to cross or bounce off the zero?
Bounce.
Why bounce? Exponent is 3. Because it's x cubed. Remember we factor out x cubed? So the multiplicity of this first one is 3. So therefore it's going to cross.
So would it be at the standard form and how you found it, where you, when you find out whether it crosses or bounces? Or
No, once you factor it out. Because the first one, we took out x to the third. This one is actually x plus 0 times x plus 0 times x plus 0. So that's why it's x to the third. And then this other one, its multiplicity is 1. It's only of the factored form we find multiplicities. So we don't know what's going to happen, but since it's a fourth order, we can bet that there's a squiggle somewhere in there. See, my way of doing these graphs is a lot easier instead of doing these charts like they're saying you're supposed to. Because what they're saying is find the x-intercepts, pick a number on this side, plug it in there, see what signs you get. If it's negative, it's below it. If it's a, but we know this already because the shape of the curve, these are the x-intercepts. We know what's going to happen at the multiplicities. Put all that stuff together, it'll graph itself. Example 2. Graph this function. 2x cubed plus x squared minus 8x minus 4. So how do you propose we factor this one out? Very good. Very good. And then what do we put this? What do we put the second parenthesis?
Negative 8x.
Very excellent. Yep. So it's negative in the middle. We have to include that in the parenthesis. So what do we factor? Leaving us with
2x plus 1.
excellent. A lot of people, most of my students always forget that plus 1. And the second one.
Negative 2.
What do they both have in common?
Oh, negative
4. Right, negative 4. And that's good. If we divide both of these by negative 4, this will be a positive 2x plus 1. Remember, this is the important part, that whatever's inside the parentheses has to be the same. Because now, since both of these are the same, I could take them out of this equation. Remember, this is one equation. I factored it out. What I have left are the coefficients. And this one, can we factor that one out? Yeah. Very good. It's a difference of 2 squares. Because this one is x squared minus 2 squared. So our zeros are at
2, and then 1.
no. The last one's wrong. But it's always the opposite sign of this one. negative 1/2.
I dropped this.
That first thing, that's always gonna be the problem. How about my y-intercept? Yep, -4. Okay, so in the multiplicities, we have the zeros and the multiplicities. So at -2, 2, and -1/2, what are their multiplicities? At the -2 multiplicity, what is? Right, because if we add all three of them, we get 3, which is the degree. All right, so let's go, that's all we need to graph. +2, -2, and then -1/2. -4 is my intercept. It's a cubic function. The shape of the curve is opposite direction. Very good. So opposite direction, increasing. So this side goes up, this side goes down. And since the multiplicities are all odd, they cross in all of them. Here's your graph. Pretty straightforward. So that's so far. Okay, the factoring's been pretty easy, and that's what the next part of this chapter is going to get into, is figuring out how to make it, how to solve all the x-intercepts without giving this easy stuff. We have one more topic in this section, is called the intermediate value theorem. Intermediate value theorem. And I'll just give you the quick and easy example of what this means. What this thing says, remember, every polynomial has to be continuous and cannot have any jumps or any holes or anything. So it has to be continuous. So if we take 2 points, or 2 x values, I should say, on the domain of our function, let's call that A and B, and we plug them into our function. So take any x values in the domain and plug them into the function. If no, x is if the answers come out different signs, then there is at least 1 point between A and B where the polynomial equals 0. A picture is worth 1,000 words, so let's look at a picture. What that says is I have some polynomial that's continuous. And I have my A and B here. If I plug in A inside the function, I get P of A. If I plug in B, I get P of B. This one's positive, this one's negative. Because they're opposite signs, there has to be at least one place where it crosses the x-axis. That's all it tells us. It doesn't tell us how many or where, it just tells us that one exists. And that's not always that accurate, because what if we had this? What if I made A here and B here? This is P of A, and this is P of B. Aerobics math. So because they both end up the same signs, they're both positive, intermediate value theorem doesn't work, even though we know that it's going to cross at least once inside there. So all this one tells us that if they end up with different signs, then we know there's at least one answer between them. So let's look at example 4. Using the intermediate value theorem. Here's our function, x cubed plus x squared minus 6x, where a is -4 and b is -2. So it's asking us, using the intermediate value, determine, if possible, whether a function has at least one zero between a and b. So we got to put those numbers in there and work them out. And at this point of the class, I don't mind if you use calculators, because you guys have proven, if you didn't use calculators, you guys can do the math. So so you don't make a mistake, use calculators if you want to. So -4 cubed is what? The answer gonna be positive or negative?
Negative.
4 times 4 is 16. 16 times 4, 64. Plus -4 squared, it's gonna be positive. 4 squared is 16. Negative times negative is positive. 6 times 4 is 24. We have -64 plus 40 equals -24. Basically, here's also a shortcut. Whenever you have a negative number inside there, if it's an odd exponent, you know it's going to be negative. If it's an even exponent, it's always going to be positive inside there. -2 cubed is -8. -2 squared is 4. Negative is a positive. 6 times 2 is 12. -8 plus 16 is +8. So what does that tell us? Yes, there's going to be a point, which can be an x-intercept somewhere. because they're different signs. All right, let's look at B. The same equation, x cubed plus x squared minus 6x. A is -1, B is 3. So -1 cubed is -1. -1 squared is +1. 6 negative is positive. -1 plus 7 is 6. 3 cubed is 27. 3 squared is 9 minus 18. 36 minus 18 is 18. They're both positive. So no, we can't tell if there's an x-intercept. Not possible.
Would there be a more specific way for you to find the exact point?
With factoring. Yeah, this just tells us, should you even waste your time factoring within this domain? Because we know it's not gonna have it. The same way we use the quadratic formula, the determinant or discriminant, is if that's negative, don't bother finding the x-intercepts because it's not gonna exist. So that's what this tells us. G of x is 1/3 x to the 4th minus x cubed. A is -1/2. B is +1/2. All right, so the first one. -1 to the 4th is 1. 2 to the 4th is 16. Minus. -1 cubed is -1. 2 cubed is 8. One times 1 is 1. 3 times 16 is 48. Negative makes it a positive. Again, the intermediate value theorem doesn't care the actual number, it just cares about the sign. So these are both positive. This one's going to be a positive number. One to the 4th is 1. 2 to the 4th is 16. 1 cubed is 1. 2 cubed is 8. 1/48 minus 1/8. We have to multiply this one by 6. We have 1/48 minus 6/48. This one's going to be -5/48. This one's going to be 7/48. So, yep. There is going to be at least one x-intercept because the signs are different. Yeah, fractions are not the best ones to have. And the last one, D. G of x equals 1/3 x to the 4th, x cubed, a equals 1, b equals 2. 1/3, 1 to the 4th, 1 cubed, 1/3, 2 to the 4th, minus 2 cubed. 1 to the 4th is 1. This is 1/1. Get a common denominator. 1/3 minus 3/3, negative 2/3. 2 to the 4th is 16. 2 cubed is 8. 1. Get a common denominator. 16/3 minus 24/3 is negative 8/3. They're both negative, so not possible. What do you think? All the intermediate value theorem is a plug and play. Just take any two x values, plug them in there, and see if the signs come out different. If it actually what's used for is to help us decide, is it going to cross the x-axis before we go through the whole process? Because if we go through the whole process of factoring or everything we're going to do there on this chapter, and there is nothing in there yet undefined, then we just saved ourselves a bunch of time doing this. So again, yeah, we have to look at specifically a specific domain which we're doing. So it's our polynomial has to exist on some domain. This is now, instead, you normally goes from negative infinity to positive infinity, but I'm looking at this specific interval here. All right, that does it for that one.